For decades, one material has given our world its tough, mirror-like shine. But that brilliance, well, it comes at a pretty steep price. So today, let's dive into the critical mission to replace a legendary but pretty dangerous industrial material. You know, this is the classic story of a hero with a dark side. On one hand, you've got hard chrome, the industrial hero. It's incredibly tough, resists wear and tear, and stops rust in its tracks. It's the definition of durable. But on the other hand, it's a total villain. The process to create it is toxic, carcinogenic, and just an all-around environmental hazard. So the global hunt for alternatives isn't just some nice idea. It's become an absolute necessity. And the core of the problem, it's not actually the chrome itself, it's how we make it. And this is the part you really need to get. The problem isn't the shiny metal, it's the process of getting it on there. Traditional electroplating uses something called hexavalent chromium, which is a known nasty carcinogen. And with environmental regulations tightening their grip all over the world, this old-school method is on its way out. It's forcing entire industries to innovate, or just get left behind.
So that brings us to our first major contender in the race for a replacement. Let's take a look at a really versatile chemical fix called Electroless Nickel. So what is it? Well, unlike old-school chrome plating, which basically zaps apart with an electric current, Electroless Nickel, or EN for short, is, well, it's autocatalytic. Just think of it like this. Instead of electrocuting a part, you just dip it into this highly advanced chemical bath, and the bath does all the work by itself. And that one difference gives it a huge advantage. To really get that advantage, imagine trying to paint a complicated gear with a spray can. You know how it goes, right? You'd get thick spots, drips, and you'd totally miss the tight corners. Electroplating has a similar problem. But with Electroless Nickel, you just dunk the gear in the bath and voila! A perfectly uniform coating forms all by itself, evenly across every single surface, inside and out. For precision parts, this is an absolute game changer.
So the bottom line here is that ENN really delivers on performance. It can match, or in some cases, even beat chrome's hardness. It gives you that perfect uniform coating we just talked about, and, most importantly, it completely gets rid of those toxic hexavalent chromium bads. It's no wonder it's already a big deal in industries from automotive to aerospace.
But, you know, nothing's perfect. EN isn't just a simple drop-in replacement. It has its own quirks. The coating's performance really depends on its phosphorus content, for one. It often needs to be baked in an oven to get to its maximum hardness. And that chemical bath has to be managed very carefully. It can also be a little more brittle than chrome if it takes a hard hit. Okay, now let's switch gears and look at a totally different class of solutions. If Electroless Nickel is a clever chemical fix, think of these next ones as, well, as high-tech armor, straight out of sci-fi, engineered for the most extreme conditions you can imagine. First up is plasma nitriding. Now this is fascinating. You're not just adding a new layer on top of the part. No. This process uses plasma to actually infuse nitrogen into the material's own surface, hardening it from the inside out. It's like giving the part a built-in suit of armor. And then we have physical vapor deposition, or PVD. This is literally creating a layer of atomic armor inside a vacuum chamber. You take a super hard material, vaporize it into a microscopic mist, and then you deposit that mist atom by atom onto the part. What you get is an incredibly thin, dense, and ultra-durable shield. And the really cool thing about PVD is that it's not a one-size-fits-all deal. It's more like a menu of micro-shields you can pick from. Need a good, solid, all-around coating? Chromium nitride is your guy. Making a high-speed cutting tool that gets crazy hot? You're going to want titanium aluminum nitride. Dealing with insane temperatures? Then aluminum chromium nitride is what you need for its superior oxidation resistance.
So what's the big payoff with PVD? It's simple, really. You get absolutely incredible hardness and durability, often way beyond what chrome can offer. And you get it all from a totally clean, environmentally friendly process. No hazardous chemical baths whatsoever.
So if it's so great, why isn't every single thing PVD coated? Well, as always, there's a catch. This high-tech performance comes with some trade-offs. The equipment to do it is really expensive. The process itself can be slower than other methods, and it's generally best for thinner coatings, which might not work for some really heavy-duty industrial parts. All right, this brings us to our next category, and this is where things get really cutting edge. These are the eco-innovations. While a process like PVD is clean, these new ideas focus on transforming the base material itself, using fundamentally green chemistry from the ground up.
And you don't have to take my word for it. As researchers like Zhang and his team point out, the goalposts have moved. It's not just about avoiding a toxic chemical anymore. It's about creating technologies that are sustainable from their very core, without giving up an ounce of performance.
A key technology here is something called plasma electrolytic oxidation, or PEO. Now, this process is amazing. It doesn't just add a coating, it uses electrochemistry to actually transform the metal's own surface into a hard, dense ceramic-like layer. The protective coating is literally grown from the component, becoming a part of it.
And just when you thought it couldn't get any cooler, check this out. By adding special compounds like cobalt titanate into the PEO process, scientists can create vibrant, stable colors. So you can get a tough, protective coating that also has a beautiful, decorative finish, all without a single drop of toxic chromium.
So you end up with this incredible package deal. You get tough, wear-resistant ceramic layers. You get beautiful, stable colors. It's perfect for sensitive applications like medical devices or aerospace parts. It completely avoids toxic compounds. And it can even be cheaper by using less cobalt. It's a true win-win-win.
So, after looking at all these incredible alternatives, what does the future of coatings actually look like? Well, the key thing to understand is this. We're not looking for one single replacement for chrome. We're building a whole new toolkit.
You know, there isn't one best solution anymore. There's only the right solution for a specific job. Think about it. Got a complex part for general use? Electroless nickel is a fantastic choice. Need insane hardness for a high-speed cutting tool? PVD is your answer. Need a biocompatible, tough, and colorful finish for a medical device? Those new PEO innovations are absolutely the way to go. And the innovation doesn't even stop there. The real frontier now is in hybrid technologies, combining these processes. Imagine using plasma nitriding to harden a surface from the inside, and then adding a specialized PVD coating on top for extreme conditions. That's the future. So what's the most important takeaway from all this? The problem of replacing toxic chrome wasn't a limitation, not at all. It was a catalyst. It's what sparked a full-blown revolution in material science, pushing us to invent a whole new generation of technologies that are safer, smarter, and just plain better for the complex world we're all building. The reign of a single do-it-all material is over. And that leaves us with a really fascinating question to think about. As we move beyond chrome, what new material, or maybe combination of materials, is going to become our next benchmark for durability and define the future of everything we build?